Hello, my name is Ilan Schnell. I would like to thank the organizers for the conference, and this doesn't, well, I don't know, this is not my laptop. I'm sorry for the delay. We had some problems here, but things are working now. I would like to talk about Llvmpy, which is a Python interface to LLVM. To understand what Llvmpy is, one would first need to talk a little bit about LLVM. LLVM stands for Low-Level Virtual Machine, but it's actually not just a virtual machine, it's an umbrella project which combines compiler, linker, runtime, compile time tools. It was started in 2000 and the initial release was in 2003. It's a compiler infrastructure written in C++, and more importantly, it uses this LLVMIR, the intermediate representation. And when you look at how compilers are designed, they have a front end usually and a back end. And in between they have some representation on which optimization passes and other things are done. And for the LLVM project, it was, I think the biggest challenge of the project was to focus on this intermediate representation, make it easy to understand and argue about, and make it human readable. And also, LLVM, unlike GCC, can be used as a library. If you have GCC, you have a lot of commands at your disposal on the command line, but you can't really, from your C code, call any of the internals of GCC. I mean, you can call GCC runtime libraries, but that's not the same as calling the libraries that GCC itself uses. If you want to, say, just use the optimizer or the backend code generator inside GCC as from the library, then that is something that would be very hard to do. So here's an example of what this LLVMIR, what it looks like. A simple function which adds two integer 32-bit numbers. It's very assembly-like. It's typed, and it can consist out of three forms: the in-memory representation, the .ll, human readable files, as we see it here, and so-called .bc, bitcode files. Okay, so what is LLVMPY then? It's just a Python binding to the LLVM library so that you get access to all the functionality, the code generator, the optimizer, everything inside of LLVM from Python. And yeah, that way you don't have to write C++ code to use LLVM. And that makes it much easier to experiment with. Well, the learning curve of LLVM itself is steep, and Llvmpy helps that. and it supports the latest version of LLVM, LLVM 3.1. Writing a compiler. So, well, I mean, Llvmpy as a project by itself isn't very useful. It's just this interface to LLVM. I mean, you have to, and there's different things you can do with it, and I'll go into some of these examples now. First one is writing a compiler. In general, what do you have to do? You have to do some lexical analysis to produce tokens. You have a parser that produces an abstract syntax tree from these tokens, and you generate intermediate from the AST, and then you have optimization passes over the intermediate representation of your code, and then you output to some maybe even native backend. If you think about Python itself, the Python compiler doesn't output to native code, it outputs to bytecode, which is then run by the Python virtual machine. So in preparation of this article, this talk rather, I found a very interesting project, which is already 3 years old on GitHub, called Pascal in Python. And what the author did was he wrote a Pascal compiler in Python using Ply and Llvmpy. So you start from the Pascal source code. He wrote a lexer and a parser using Ply. You build up your IR from that, and then you use Llvmpy to output to native code. For example, x86. And the project has very readable code. It's not a lot of code, only 1,500 lines of code, which is not a lot of code for a compiler. I mean, that's the code, of course, only that you have to write yourself. And it serves as a very good example, even though, I mean, most people wouldn't necessarily want to write a Pascal compiler, but writing a compiler for other languages is very similar, and this code illustrates very well how this can be achieved with Ply and Llvmpy. So Number is another project which uses LLVM, and in Number, Python bytecode is used as the source, which is then translated to LLVM IR code. And what you can do in Number is you can write little snippets of code, of Python code. You can decorate them and then create inner functions for, like U functions for, that can be then executed by NumPy in the inner loop of a kernel. And using Llvmpy, the big advantage is that you can target multiple architectures. You can target, in particular, GPUs for your computing, for your compute units. And here's an example of this. So on the left bottom, we have a small Python function, and then you put the vectorized decorator on top, and in some cases it can then suddenly run 100 or 1,000 times faster, and it does that by creating Llvmir code, and the Llvmir is shown here. Another interesting example which I came across recently is Llvmpy, an LLVM bitcode import tool that David Beasley wrote just a few weeks ago, or a month ago maybe. And so to the left, I just showed how little effort it takes to write very fast Python code. So you have this function, this Fibonacci number function written in C. So the red shows what the C code looks like. Then you use clang to compile it to object code, to actually to this LLVM bit code. And yeah, then you start Python, you import Llvmpy. Before you import the bit code, so that's why bytecode is imported before import fib, and then you run the function inside your code. And that's all you have to do. And under the hood, it uses C types to load and execute the function, but it uses LLVM, rather Llvmpy, to inspect the bit code for the function signature. I mean, the code I show here could be almost as short if it was if I just used C types, but with C types you would have to tell it the signature of the function you're calling, and yeah, because I mean that's already included into the bit code that LLVM produces. So this diagram just shows how the people at my company that I work for, Continuum Analytics, how we envision the future of the software stack. You have LVM on the low level as a plateau to combine different domain-specific languages, Fortran, C, C++, and then on the higher level you have Python. And that, of course, can plug into SQL, into R, into other languages as well. Llvmpy is seeking developers. It's on, this is the website, llvmpy.org. It's hosted on GitHub. It's a little bit raw still. It supports Python 3. It supports Python 2.6, 2.7, and Python 3, but it can certainly need more improvements, in particular on the documentation side. Okay, thank you for your attention. I'm sorry for the delay. Yes? Well, it works on Windows now.
How do you get it on there?
Oh, well, Llvmpy is relatively hard. Well, I mean, you have to compile LLVM first, or have it on your system. The easiest way to get Llvmpy working on your system is actually using the Anaconda distribution. Anaconda is a distribution of packages and libraries for high-performance computing that we provide from Continuum Analytics, and that includes Llvmpy, also on Windows. That was a very good question, because otherwise I probably would have forgotten to bring Anaconda up. Are there any other questions? Hmm? I didn't understand the question. Yeah? Statically? Yeah. Yeah. It includes the JIT. Although the term JIT is sometimes misused, I feel, in the LLVM world, because they talk in general about JIT whenever they just mean compiler. Okay, any other questions? Well, thanks again.